Okay, here we go. This is the Unit 10 quiz review. So I'm just going to work through this entire thing, so it will probably be a longer video. I think this is 4 pages. So feel free to skip around in the video, and we'll go from there. So this first one here, we got two circles. True circles A and B have different radii. Student dilates circle A at its center by a scale factor of 10/3. All right, so this number 10 divided by 3, that is 3.3. And that's going to make it the same size as circle B. So we dilate circle A, it gets bigger. All right, they want to know, hey, what scale factor could have been used to make circle B the same size as circle A? Since we know circle B is bigger than A, all we have to do is we have to take this scale factor and just flip it upside down. So we're going to say K equals 3/10. All right, so anytime they switch that scale factor up on us, or anytime they want us to go the other direction, all we do is we're just going to take the reciprocal of whatever scale factor is given. All right, now another one. Give number 2, give an example of concentric circles or something that is concentric. Just think of the Target logo, right? That is concentric circles. You got red circle, white circle, another red circle. They all have the same center. Remember, concentric circles just mean that they have the same center. All right, number 3, determine the translation vector that would map the center of circle A onto the center of circle B. So we're ending at circle B. So what we need to do is we need to just go coordinate by coordinate. So we have the x coordinate and the y coordinate. So what we just need to do is 3 minus 0 coordinate, x coordinate of circle B minus x coordinate of circle A. That just equals 3. Right? Then just do the same thing with y's. 6 minus -4, 6 minus -4, that's really plusing a positive, that gives us a 10. So what we need to do is we need to translate to the right 3 spaces and up 10 spaces. All right, so we're starting at circle A and we're ending at circle B. Right, so if we started at -4 units down, we'd have to go up 10 spaces to end up at 6 spaces above the x-axis, or above the x-axis. All right, same thing here. So start with B, just B minus A. So -1 minus 2. -1 minus 2, that gives us a -3. 5 minus 9 gives us a -4. So if we want to go from circle A to circle B, we're going to have to go to the left 3 spaces and down 4 spaces. All right, now, what scale factor would make circle A the same size as circle B? Okay, so what we're doing is we're going from circle A to circle B. So compare the radius of circle A to the radius of circle B. Okay, what we need to do is we need to find out the scale factor. Since we're getting bigger on this one, since circle B is bigger than circle A, our scale factor, our K value, it needs to be bigger than 1. So we just do 8 divided by 5. All right, 8 divided by 5 is 1 point something, 1.6. So that's definitely bigger than 1. Right, had we made a mistake, maybe we accidentally wrote 5 divided by 8. If you do 5/8, that's smaller than 1. Any scale factor that's smaller than 1 makes our circle smaller. But we know circle B is bigger than circle A, so our scale factor needs to be bigger than 1. All right. Now, we have to be careful on this one. Same thing, except they're giving us diameter. When we do scale factors, we are talking about the radius. So the radius of circle A is 7 meters, and the radius of circle B is 4. All right, so we have to be careful about that. But notice how circle B is smaller than circle A, so our K value, our scale factor, needs to be smaller than 1, and the fraction that is smaller than 1 is 4/7. We don't want 7/4, because 7/4 is bigger than 1. We want 4/7. All right, let's just keep on keeping on. So basically, we're going to tie 3, 4, 5, and 6 together, and we're just going to do it all in this one picture here. So given this image, we want to know the translation vector and the scale factor going from circle A to circle B. Okay, so just compare the centers. So if we start at circle A, we have to go left 2 spaces. And whenever we go left, those are negative numbers. All right, so we have to go left 2 spaces. We have to go up 3 spaces. That's our translation factor, just left 2, up 3, or negative 2, comma, positive 3. Now, when we compare scale factors, let's look at the radius of each one of these circles. So the radius of circle A is equal to 3, and the radius of circle B is equal to 1, 2, 3, 4, 5, 6, equal to 6. Okay, so our scale factor, we want to end up at B, so K equals 6/3, and we can always reduce any fraction, so let's call that 2. So K equals 2. All right, let's do it again. Starting at A, ending at B. So with translation vectors, we always want to take care of the left and right movements first. So counting these spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going 11 units to the right, and 1, 2, 3, 4, 5, 6 units up. The radius of circle A is 2. The radius of circle B is equal to 4. So the scale factor that we have to multiply A by, so we're going to say K equals 4/2. All right, 4 divided by 2, that just gives us a 2. All right, so we are 1/4 done with our review. Let's keep on keeping on. All right, here we go. Number 9, name each as central angle, major arc, minor arc, or semicircle. So remember this notation, the measure of arc AB. So we don't want an angle, we want arc AB. So that is this right here. That is definitely smaller than half of a circle. So this is a minor arc. All right, angle AFB. So starting at AFB, that's definitely a central angle. All right, how about this one? AFD. That's just another central angle. All right, these two are a dead giveaway. Right? We literally have the angles in there. They are central angles. Now this next one, measure of arc BCE. Since there's 3 letters, it has to either be a semicircle or a major arc. All right, so starting at B passing through C, and ending up at E. Okay, this one's a semicircle because BE is a diameter. So this one is a semicircle. All right, let's see, EBA. So starting at E, passing through B, and ending at A. So we're going all the way around. That's a major arc. All right, BFC, starting at B, going to F, C, central angle. And last but not least, measure of ED. Starting at E, going to D, that is a minor arc. All right, let's look at this one now. So let's see, in circle P, measure of angle 1 is congruent to angle 2. Measure of angle 2 is 2x plus 10. Okay, and the measure of angle 1 is 4x minus 50. Segments, okay, so those are diameters. Find everything we know. Well, we know that 1 and 2 are congruent, so let's just go ahead and solve for x really quick. 4x minus 50 equals 2x plus 10. Do a little quick algebra. 2x equals 60. X equals 30. So they don't want x though. So we can figure out what this arc is though if we just plug that back in. 30 times 4 is 120. 120 minus 50, that gives us 70. Okay, so if arc DE is 70 degrees, then EC is also 70 degrees. So let's see, do they have that? They have EC, okay, so that's 70 degrees. They want AB, we don't have that one yet. DC. So starting here, going here, that's 140 if we just add those two together. Let's see, what else do we know? Okay, so AC is a diameter. Right? So this entire thing right here is 180 degrees. So 70 plus 70 gives us 140. So this has to be the remaining part to add up to 180. So we know that this is 40 degrees. So AD, do they want AD? They don't want AD. So can that help us? That can help us because if this is 40 degrees, we know that these angles are vertical. Okay, so that means they're congruent. So that means this has to be 40 degrees as well. Let's see, let's get another color. We know that this angle is congruent to that angle by vertical angles. So we have this arc here is 140 degrees. And we could check that. We could make sure we know all 5 of those things need to add up to 360 degrees. So 70 plus 70 plus 40 plus 40 plus 140. There's our 360. So that all works out. All right, so now we have everything we need. So measure of arc AB, that's going to be 140. Let's see, CPB, central angle CPB. CPB, that's 40 degrees. Remember, the arc measure is the same as the central angle measure. CBE, CB, arc, major arc CEB. So starting at C, passing through E, and ending at B. Okay, that's everything on this circle except for the 40. So it's 360 minus whatever that piece is. So 360 minus 40, that gives us 320. And then last but not least, CEA. Starting at E, passing through E, and ending at A. C to A, well, we know that AC is a diameter. So C to A has to be 180 since it's a semicircle. But 70 plus 70, that's 140. 140 plus 40 is 180. So there's a few ways we could have done that one. All right. Let's see. Let's talk about radians and degrees now. So convert 95 degrees to radians. So 95, whenever we convert to radians, keep in mind that pi radians equals 180 degrees. That is our conversion. Okay, so we want to end at radians. So what we need to do is multiply this by pi over 180. If we want to turn that 95 into a fraction by putting it over 1, that gives us 95 pi over 180. And then all we need to do is reduce that fraction. 95 divided by 180. I have no idea what that reduces down to, but we can use our calculator. That gives us 1936. So we can call this 19 pi over 36. All right, let's do it again. 115 degrees over 1 times pi over 180 degrees. All right, we want the degrees to be diagonal so they cancel each other out. And all we're left with is the radian unit. So 115 pi divided by 180. Let's go ahead and simplify that fraction. That gives us 23 over 36. So this is 23 pi divided by 36. That's how we go from degrees to radians. If we wanted to go the other direction, if we wanted to start out with radians and go to degrees, instead of multiplying by pi over 180, we do the opposite. We multiply by 180 over pi. So let's do that. 3 pi divided by 5 times 180 over pi. Just multiply straight across. 300 times 3 times 180, that's 300 plus 240, 540 pi divided by 5 pi. All right, so notice how you got a pi on top and on bottom. Those cancel, so we're just left with 540 divided by 5, which gives us 108 degrees. Right, so if you see 3 pi over 5, that's really just 108 degrees. All right, let's try it one more time. Pi ninths times 180 over pi, that equals 180 pi over 9 pi. The pi's cancel out. 180 divided by 9, that's just 20 degrees. Right? And that is how we go from radians to degrees. All right, halfway done. Find the length of the arc and the area of the sector. Okay, so there, let's see, there are two formulas for each one of these. This one looks like this problem was given to us in degrees. This problem was given to us in radians. That's okay because we know arc length, we used an S for arc length, was equal to theta over 360 times 2 pi times the radius. We have everything we need. All right, so 150 degrees is our theta, that is our central angle. Looks like our radius is 19. Let's just plug everything in and go from there. So 150 divided by 360 times 2 times pi times 19. We can plug that whole thing into our calculator. 150 divided by 360 times 2 pi times 19. Whoa. Times 2 pi times 19 gives us 49.74. All right, so that was the arc length. The area formula, the area of the sector, again, is equal to theta over 360 degrees times pi r squared this time. So 150 divided by 360 times pi times the radius squared times 19 squared. Let's see what that gives us now. 150 divided by 360 times pi times the radius squared. 472 point, we'll call that 55. 472.55. Okay, now with number 27, a little bit different. They're asking for the same thing, but they're giving us radian measures this time. So if you remember these formulas for radians, that's S equals, instead of saying theta over 360, we swapped that out with a 2 pi. We knew that the 2 pi's canceled, so we had the arc length is equal to the central angle times the radius, or theta times r. So arc length on this one, super easy. There's 3 pi over 4 times 13. And 3 times 13, that gives us 39. So we're left with 39 pi over 4 as our arc length. Now the area of the sector, let's see, area of the sector is equal to, again, we swapped out this 360 for a 2 pi. Just the pi's canceled this time, and we're left with 1/2 times theta r squared. So let's go ahead and do that again. 1/2 times 3 pi over 4 times 13 squared. And I think that's 169. So we're going to call that 169 over 1. That's going to be equal to 3 times 169. That's 507. 507 pi over 2 times 4 is just an 8. I'd be willing to bet that doesn't simplify. 507 divided by 8. Yeah, so we can leave it as 507 pi all over 8. That is the area of this sector right here. All right, so that's how we do it with degrees and how we do it with radians. All right, let's see here. Circle has an area of that. If the sector of a circle has an area of that, find the measure of the central angle. Use 3.14 as pi. Okay, so circle has an area. So we know the area of a circle is equal to pi r squared. All right, so let's plug in what we know. Let's draw a picture first. So we have a circle. We know the area of this entire thing is just 502. And then we also know the area of just this sector. We know that that is 125.6. So if you think about it, what we can do is we can divide those 125.6 divided by 502.4. Wow, okay. So that actually worked out really well. It ends up being 0.25. So right off the bat, you can take a shortcut, and I just know that this angle is pretty sure it's going to equal 90, but let's just go ahead and do the math just so you guys can see that for yourself. Let's see. Area of 502.4. 502.4 equals, they're telling us to use 3.14 is pi, so let's go ahead and do that. 3.14 times r squared. What I'm going to do is I'm going to take this 502.4 divided by 3.14 on both sides, then square root it, so I got r. So the radius of this circle ends up being 502.4 divided by 3.14. Take that number, square root it, that gives us, no, that's not a nice number. Okay, so I'm going to do this, 12.65. Okay, so I'm just going to call it 12.65, that's fine. If the sector of the circle has an area of 125.6, find the measure of central angle. Okay, so now we need to use the area formula of a sector. The area of the sector is equal to theta over 360 times pi r squared. We have the radius, we know pi is 3.14, and we have the area of the sector. So we have two of the three variables we can solve for the third just by using some algebra. So we have 125.6 equals theta over 360 times 3.14 times r squared. So that is 12.65 squared. And so that actually ends up being pretty close to 160. So here's what we can do. I'm going to divide both sides by this number. Okay, so if I do that, I can type this whole thing into my calculator if I want. 12.65 squared times 3.14. That's 502 point. We'll say 502.47. Okay. Which actually that ends up being the area of the circle. Okay. Anyways, so we have this number right here. I don't know what that is. 125.6 divided by 502.4. That gives us 0.25. So we have 0.25 equals theta over 360. Right? Multiply both sides by 360. 360 times 0.25, that just ends up being 90 degrees. Right? And there we have it. Right? Find the area of the shaded region. Leave your answer in terms of pi. Okay, so this one, it looks tricky, but it doesn't have to be. All right, let's think about this. Let's try to do this as efficiently as we can. What we have is we have half of a circle with radius 5. We have a full circle with a radius of 5. And then we have another half circle of radius 5. So really what we have here is one whole circle, another whole circle. We have two whole circles. All right, so let's just find the area of this circle and double it, and that's going to give us this non-shaded region. So the area of a circle is pi r squared. So the area of the circle is equal to pi times r squared. 5 squared is 25, so 25 pi. Okay, so as a decimal, 25 times pi 78.54. So that's just the area of one circle. Since we have two full circles, let's just go ahead and double this number. Okay, so circles, the area of the circles equals 157.08. All right, now this rectangle here, we know the dimensions of this rectangle. Okay, we know that this is a semicircle of radius 5. Okay, so we know that this is 5 centimeters. We know that this is 5 centimeters. Therefore, we have this length equals 10 centimeters. Let's look here. This is 5 centimeters. We've got another 5 centimeter radius there, another 5 centimeter radius here, and another 5 centimeter radius here. So we know this rectangle has a length of 20. So the rectangle is just 20 times 10, gives us 200. So if we just wanted to find the area of the shaded region, subtract these two numbers. Okay, and if we just do 200 minus 157, that just gives us 42.92. Yeah, right? 200 minus 157. Yeah, okay, 42.92 centimeters squared. All right, so what we did in this one was we found the area of one circle. Since we had two full circles, we doubled it to get this 157. Okay, we found the dimensions of this rectangle using the radii of these circles, and it ended up being 10 by 20. 10 times 20 is 200. Subtract these two numbers. That's how we get the shaded region. Okay, this one, theta equals 90. Okay, we want the shaded region. Actually, theta does not equal 90. Theta is actually the whole thing. So theta really equals 360 minus 90, which gives us 270. Okay, so the area of the sector is equal to 270 divided by 360 times pi times the radius squared. So 270 divided by 360 times 36. So there's two ways we do this. We could call this 27 pi, or we can get a decimal. 27 times pi. 27 pi gives us 84.8. 84.82. All right, almost done. Last page. Let's see here. This one a little more involved because we have central angle up 120, a radius of 30. We need to figure out the area of this triangle. We need to figure out the area of the entire sector. And then what we have to do is subtract away this triangle. Okay, so we'll start off with the triangle. The area of the triangle, we're going to have to use a trig formula, is equal to 1/2 AB times the sine of theta, or I guess A of this side times the angle between the two. Okay, so that equals 1/2 times 30 times the sine of 120. Okay, that's going to give us a decimal. So the area of the triangle equals 0.5. 30 times 30 is 900 times the sine of 120. That gives us 389.71. Okay, the area of the sector is equal to 120 over 360 times pi times 30 squared. Now let's go ahead and plug all of that into our calculator. Again, 30 squared is 900, so 120 divided by 360, I think that's a third. So 1/3 of 900 is 300. So the area of this sector, the entire thing, is equal to 300 pi. 300 pi, which we can multiply that pi in to give us a decimal. So 300 times pi is going to be about 900 something, equals 942.48. Okay, so to get just this shaded region here, just do 942.48 minus 389.71. So the shaded area equals 942 minus 389. 942.48 minus 389.71 gives us 552.77. Okay, the area of a sector is 12 pi and its radius 3. Find the length of its arc. Okay, so area of the sector equals 1/2 theta r squared. We would use this formula because they're giving us an area in radian units. So plug in everything you know. So we have 12 pi equals 1/2 times theta times 3 squared is 9. Okay, so if we wanted to, we could rewrite this. So 12 pi equals 9 theta over 2. So if you had to do all this, multiply both sides by 2. So you got 24 pi equals 9 theta. Therefore, theta, our central angle. Oh, find the line of this. Dang it, I should have read the directions. Okay, theta equals 24 pi. 24 pi over 9. Okay, now we need to use this theta in this formula. We know arc length, S, is equal to theta times the radius, which is 3. So what if you do 24 pi over 9 times 3? Okay, that's going to give us 24 thirds. 24 divided by 3 gives us 8. So this gives us 8 pi. All right, 33. The length of the arc of a sector is 3 pi and its radius of 2. Find the area of its sector. The length of the arc, so an arc length. Okay, so S equals theta times r. Therefore, 3 pi equals theta times 2. Therefore, theta equals 3 pi over 2. And they want us to find the area of the sector. Okay, so the area of the sector is equal to 1/2 times theta times the radius squared. So that is going to be 1/2 times 3 pi over 2 times radius squared. 2 squared is 4, so I'm going to call this 4. Might as well call it 4 over 1. That gives us 12 pi over 4. 12 divided by 4 is 3. That gives us 3 pi. Okay, almost done. Measure of angle AOB. AOB 75 degrees. AO is 5 centimeters. Okay, find the area of the shaded region. So this is going to be just like number 30. So find the area of the triangle, find the area of the sector, and then subtract the 2. No, it's going to be just like this one, just like 31. Yeah, pretty much just different numbers. So we have area of the triangle equals 1/2 times one side of the triangle times another side of the triangle times the sine of the angle between those two sides. Okay, and that gives us 0.5 times 25 times the sine of 75 gives us 12.07. The area of the sector is equal to 75 over 360 times pi times the radius squared, which is 25. 75 divided by 360 times pi times 25. That gives us 16.36. Okay, so to find just this shaded area, subtract these two numbers. All right, so 16.36 minus 12.07. All right, last one. Measure. Okay, so we're using this picture again. AOB is pi over 2. AO is 6 centimeters. Exact value or in terms of pi. Okay, so there's two ways we could do this one. Okay, let's find the area of the triangle. Area of the triangle is equal to 1/2 times 6 times 6 times the sine of, let's do this, instead of saying pi over 2, we know pi over 2 is equal to 90 degrees. Okay, that's a conversion you could do. I guess I should show my work on that. Pi over 2 times 180 over pi, that equals 90 degrees. All right, so let's call this 90 degrees. Okay, what's nice about the sine of 90, sine of 90 degrees, that's just equal to 1. Okay, so what this really ends up being is half of 36. Okay, so the area of this triangle, that is just equal to 18. Now the area of the sector, we're going to get pi units because they're giving us a radians and they're asking us to keep it as an exact value. So what we're going to end up with is 1/2 times pi over 2 times the radius squared, which 36, let's see, this gives us 36 pi over 4, which gives us 9 pi. So the shaded region is equal to the area of the entire sector, which is 9 pi. So 9 pi minus the area of the triangle, which is 18. And they told us, hey, keep this thing as an exact value. So this is our exact value. So that 9 minus 18 is our final answer. I guess we can call this centimeters squared. Okay, that was all 35 of these problems on your quiz review.